is 4.150. A 100 kilogram uniform rectangular plate is supported in the position shown in H A and B and BY cable. DCE that passes over a frictionless hook at C, assuming that the tension is the same in the both parts of the cable. So the question is, determine A, the tension in the cable, B, the reaction at A and B, and assume that the hinge at B does not exert any axial thrust. So for the free body diagram, this part is the point A, which is AY, AZ, and AX. And this one is BY and BZ. So the tension C and E is we need to determine it after we find the solution. So for the solution, force B divided by A is equals to 960, which is the distance between D and E, minus 180, which is lie in the 108, which lie in the x-axis, I, is equals to, so 960 minus 180 is equals to 780I. And the force between G over A. So 960 divided by 2 minus 90 J I plus 450, which is divided by 2K is equals to 960 divided by 2 minus 90 is equals to 390I plus 50 divided by 2 plus 225K. So RCLA, say, divided by A is equals to 600I plus 450K. And the tension in cable DCE so vector CD is equals to negative 690I plus 675J minus 450K. So CD is equals to 1,600 and vector CE is equals to 270I plus 675J minus 450K. So CE is equals to 855 and TCD is equals to T over 1665, which is line CD, and times negative 690I plus 675J minus 450K. And for the tension in point CE is equals to T is over is over 855 m times 270I plus 675J minus 450K. So is equals to mass times gravity, which is, we have a mass of 100 kilogram times 9.8 meter per second squared, which is the gravity, is equals to negative 100 times 9.8 is equals to negative 981 Newton joules. So the next is, we must find the moment, summation of moment in A. So A is equals to 0. So R C divided by A times tension in line CP plus R divided by C over A times tension in CE plus tension in J divided A times the times work plus R divided by A over A times B is equals to 0. So we must solve it using matrix equation. So I J K equals to 600, and then J is 0 and K is 450 times TCD, which is negative 690, 675J and negative 450K times the tension in CD, which is 1065 plus RCLA, which is I is equals to 600 and J is equals to 0 and K is equals to 450, and the tension in CE is 270 and 675 and K is 450 times tension in CE, which is 855 plus RB plus T tension in J divided by A, which is I is equals to 390 and J is equals to 0 and K is equals to 225. And for the second part, I is equals to 0 and J is equals to 981, which is the work, and 0 plus R times B divided by A, which is I is equals to 780 and J is equals 0 and K is equals to 0 and I equals to 0 and BY is not determined. Also the BC is equals to 0. So first we need to get the coefficient of I. So by using cross multiply, we get negative 450 times 675 T over 1665 minus 450 times 675 times the tension divided by 855 plus 227.25 times 10 equals 0, and then the tension is equals to, so to simplify, you will get the tension of 344.6 Newton, or approximately equal to 345 Newton. And next is to find coefficient of I, a coefficient of G rather. So 690 negative 690 times 450 plus 600 times 450, so times TCE, which is T is equals to 344.6 over 1065 plus 270 times 450, 270 times 450 plus 600 times 450 times the tension, which is 344.6 divided by 855 minus 780 BZ is equals to 0. So BZ is equals to 185.49 Newton. Next is we must find the coefficient of K. So we must find the coefficient of K. So 600 times 675 plus the tension, which is 344.6 divided by 1065 plus 600 times 675 times the tension, which is 344.6 over 855, which is the TCE, minus 322.59 times 10 to the power of 3 plus 780 BY. So to simplify, BY is equals to 113.2 Newton, or to B is equals to BY plus BC. So B is equals to 113.2 Newton plus 185.49 Newton. So for the summation of F equals 0, A plus B plus TCD plus TCE plus work is equals to 0. And so for the coefficient of I, EX is equals to 690 divided by 1065 times the tension, which is 344.6 plus 270 over 855, which is the TCD, times the tension, which is 344.6 is equals to 0. So AX is equals to 114.4 Newton. And for the coefficient of J, AY plus 113.2 plus 675 divided by 1065 plus 670. I forgot the tension times 344.6 plus 675 over 855, which is the TCE, times 344.6 minus 981, which is the work, equals 0. So AY is equals to 377 Newton. And solve for the coefficient of K, AZ is equals to 185.5 minus 450 over 1065 times the tension, which is the 344.6 Newton, minus 450 J over 855 times the tension, which is 344.6, equals to 0. So you will get the answer of AZ is equals to 141.5 Newton. So summing up, A is equals to 114.4 Newton I plus 377 Newton J plus 141.5 Newton K. So this is the answer for the summation of moment of A. And that would be all.